angles which are going to be very, very important in your calculations. And then also understanding things such as coterminal angles. You want to understand what is a coterminal angle, but luckily enough, those are things that we've already talked about. Okay, so then what are we going to do? So then we're going to look at, so we'll start with pretty much the basics. So we are going to say that sine x. So you are told solve for x. I know that sounds too basic, but there's a certain concept that I want us to appreciate. So what then this tells us is that if we are told to solve for for sine sine x, and then they just leave it like that and then ask us to find what x is, what's going to happen is, if we solve for this, we are going to have so solving for this, we are going to have x being equal to what? Being equal to pi over 6. For this one, I'm going to use some radians so that people get used to seeing radians. So for radians, this is the same as what? That's 30 degrees, isn't it? So that's the, now they've not given us a range for which our values should be in. So then this means that you just have to keep on giving values, giving values, giving values. So then what you then do is, since you found that answer, then you ask yourself and say, in which quadrant is sine positive? Because the answer, the angle that you have to give only has to be for a case in which uh, sine in positive. So we know last time we said, oh, students take coffee. So meaning it's in the first quadrant, and this is 30 degrees, that's in the first quadrant. So let's now look at the second quadrant. How do you find an angle in the second quadrant? You simply, what do you do? Subtract the this initial angle from what? From 180, isn't it? So you say minus pi, then that. Then what are you going to get? You are going to get 5 pi over 6. Then from this, then what are you going to do? Then you are now going to look at the what? The coterminal angles. What do coterminal angles tell you? Those are angles which are things like, if you've got 30 degrees, the value is going to be the same with uh, is it 33 degrees? Let me just confirm. Or 330 degrees. So why that is very, very important for the coterminal angle is that they are going to give you a great deal of idea with how you can solve when they don't give you what's this, when they don't give you a region, or when they don't give you a limit or a range for what your answers are going to be. So this one is going to be negative, negative, negative half. So this one doesn't fall into it. Okay, but again, you can start looking at values such as uh you can start looking at values such as, okay, what if we have a value such as maybe let's say 390 degrees. So 390, how are you getting 390? Remember, you know that any value, let's say we get the 330 that I found, where is 330 going to be? 330 is going to be where? In the fourth quadrant. That's why you see that cos rather sine 330 is going to give you what? Gives you negative half, meaning it's the same magnitude but it's having a negative sign, and we don't want that. So what then do? You want an answer which is going to be where? In the first quadrant. So what do? You say, okay, 360 plus 30. 360 plus 30 is going to come like now. Let's say if 30 is there, right? If 30 is there, meaning 360 is going to come like that. And for sure, when you say sine 390, that's going to be half. Okay? 390. Okay? Of which you can write this in your in radians will be that. But usually, so you see that answers can be as many as you would want them to be. But the key thing is there's this generalization where you say the first answer that you found, the acute angle that you found, you can say the first angle that you found plus 2 pi n. Okay, where you would say n is going to be 0. So then you can also have plus or minus 1 plus or minus 2. And this is just coming from the point is that remember these graphs of sine, they are what? They are symmetric, okay? So that's why you would see certain things such as yeah, so this is a good generalization, okay? But the point to take home usually in our questions, they usually give you maybe from 0 to 360 because they understand that there are so many answers that you can find, right? But if you've been asked to find to find all the solutions, then that's the approach that you would want to take. So I know these are a little bit simple, so let's try to look at something a little bit hard. Okay, so so really that's how you can find all the values. Then the other thing is, let's say I've got this. So when you have something like this, of course you do it the same way you did for that other one, and you say so there's that. So now the question that you have to ask yourself is what angle is this? What angle is going to give us tan being that value? Can someone give us what that angle is going to be? Okay, so before you can start putting out your angles, you first it's going to be it's going to be tan 30. Okay, so now this tan 30, you've seen that I've cancelled it. So I'm saying 30 degrees, but it's not my answer. You've seen, do you know why I've done it like this? I've done it like that because if it were 30 degrees, 30 degrees is where? Is in the first quadrant. It means that my tan would have been positive. You get it, right? But because my tan is negative, it means that yes, this 30 is just giving me the acute what? It's giving me the acute angle. Okay, but then if it was 30 degrees, yes, if it was 30 degrees, it means that it would have been here. It would have been where all are positive. But I know that this is negative, right? You could see that the answer is negative. So then you have to start saying, okay, what could be the value? It means that my value has to be in the second quadrant and in the third quadrant where tangent is what? Is negative. Okay? Where tangent is going to be what? Where tangent is going to be negative. So then the question now remains on how can you find these answers. So how do you get the actual angle from 30 to get something in quadrant 2? So what you do is you say the angle that we are looking for, the x that we are looking for, is what is the acute minus what? Minus 30. Like the same thing we're doing for vectors. Remember the time when we're doing vectors. So that's about it, right? So we have that. Okay, so we have that. Then from there, what else can we do? Then we now have, so for now, let's just be working with the ranges that you are usually given, so that yeah, so that we don't have any issues with this. Let's just use this because that's more realistic than having to look for all the angles. So then you are now asking yourself, so I found this angle in the second quadrant. Let me now find in the third, or sorry, in the fourth quadrant. How am I going to find my angle in the third quadrant? So you're going to find your angle in the third quadrant by saying, um, remember how we find angles in the third quadrant? We say, um, okay, so we say 360 minus that acute angle which was 30, right? So we're going to have what? 330. So that's basically how you would find your answers. Of course, using this range here, right? But of course, you know that you can go on and on and on and on and on with regards to this. So for these ones, in case you're asked to find all the angles, what you do is say x, then this angle that you started with, you can putting it in radians, 30 degrees is 5 pi over 6 plus by n. So meaning using this, meaning with this, where n you would say, okay, so that, then you also use this one which you found here. Okay, so there we have it. Then n is going to be, okay, yeah. So again, that's some generalization that you may want to take note of. So really, that's really the key thing about it. So we could go and on and on and on for the other kinds as well, but with that, once you know that, then that's really pretty good enough. So now let's now look at things which are a little bit more complex. So remember that for sine, we were saying the answer you found 2 pi n. That's the same thing for cos, okay? So even for cos, when you find your answer plus 2 pi n, yeah, then you find for the other answers again. But you know, for tan, the period is pi, so that's why we are adding pi. So you can think of it like that, right? So having done relatively simple questions, let's look at this one. Then we'll begin to look at those ones where you have to deal with the double angles before we can look at the quadratic equations. Okay, so then what you're having with this one is you take the one to the other side. So now, I'm sure you know from sides that you can break down something into that. Square root of 1 is 1. Square root of 2 is, okay, of course, it will be a point. So you just leave it in a standard form. But then what do we do in this case? This becomes problematic because again, we know that you never leave a side at the denominator, right? So you have to rationalize this. So to rationalize it, you're going to say, so you're going to have that and that. So we're just rationalizing this, right? I don't know why I'm failing to write this. Okay, so you're going to have, so you're going to have that over that, right? So that's what you're having. So then what you're going to do there is, so you've got that, right? So we are just going to replace here, since we always have to rationalize sides over what? Over 2. Then since it's plus or minus because of the square root, so you then say, okay, then also, now once you've got an equation that is like this, you are then looking at certain things, right? So in which quadrants is sign going to be positive? It's in the first and what? First and second. Then where is it going to be negative? It's going to be negative in the third and fourth, which is this one, right? So now, what this means is because you've got this one which has got a positive and this other one which has got a negative, so you're going to have four answers, two for this one, and then of course we are using this range. Okay, we are using this range, or it can be 0 to 2 pi. But yeah, so we are using that range. So meaning that we are going to have answers in all four quadrants. Okay, of course, for the first one, we are going to have our answers which are going to be in the first and second quadrant, where our sign is what? Where sign is positive. And then for the second one, this part where I'm using blue, we are going to have where sign is what? Is negative, which is going to be the third and fourth quadrant. So since these special triangles have to be on your fingertips, what is the value of sine x square root 2 over 2? So remember, you have to know these, you have to know them. Um, you have to know them. So what value is it going to be? What's the value of x? So it's going to be 45. Yes, thank you. So it's going to be 45 degrees. So that's an answer because it's positive and it's in the first quadrant. So then what then do we do? We try now to find an answer which is where, which is in the second quadrant. Second quadrant, how do we find something in the second quadrant? Second quadrant, we get what the answer we found, subtract from 180. That's going to be what? 135. So you're going to have what? So you're going to have 140, or sorry, 135 there. And if your question is in radians, you just convert these things. Huh? You just convert these things. But yeah, so that's really about it. So now we now go to the other part. And this the main reason why I've put this question is many people forget that when it's a square root, you have to give two answers. You have to give two answers. Many people make so many mistakes and they see their marks and they're like, okay, what happened? What happened? So please, it's very, very important to take note of this. Okay, so having done that, let's go right into it. So now let's now look at this. What's going to happen now in this particular? So what are we going to do now in this particular one? So where we have so then can someone tell us what this answer is going to be? What our x is going to be here? In short, people, we are looking at how we can get a value of 45 as an acute to get values in the third and fourth quadrant. That's what we are doing. So again, remember here, if you've been asked to find all the other angles, you just add 2 by n, 2 by n, then you can find all the angles. But anyway, usually they'll give you a range, but that's how you could do it. But so now, to find an angle in the third quadrant, you say 270 minus the acute angle you found, which was what? 45. Then what are you going to get? 270 minus 45 is what? Is 225. So that's an angle that's in the third quadrant. So that's an angle that's an angle that's in the third quadrant. Okay, so now how do you get an angle which is in the fourth quadrant? Again, the same thing. You get that angle that you found, the acute angle, and then you actually subtract it from 360. Maybe some people have been using a different method. I'll explain that one as well. So for the third quadrant, you will realize that you can actually, like for the third quadrant, for this one, sometimes you could even do it as 180 plus the acute angle that you found. That's 45. You still get what? 225, huh? So you could also do it like, and this is the most common way actually of doing it. So, but otherwise, so whenever you've got a question that has got a square root, please don't forget to give two angles, huh? Many people have lost good marks because they forgot about that. So that's an important. So now, before we can start looking at quadratic equations, let's look at those quadratic equations where you have to take into consideration the double angles and things like that, because those ones are pretty much common as well. So that's what we are going to dive into now. So if you've got something like this, so um okay, so what's the value of okay, yeah, so what's the value of what's going to be our answer there? By our answer, I mean what should be the value of what in 2x for us to have half. So the other way you could see it is where some people may actually substitute this for something else. So like how they want to do it is they will say maybe I they put it 2x, maybe they make it like that. But anyway, what you do in this case is that you just ignore what's in the bracket and then just focus on those brackets. Look at it as one thing. So just look at it like it's theta. All of this, just look at it like it's one thing. Okay, don't consider the 2x, the sometimes it can be half. Don't consider, just look at it as what? As one thing. So that's the first thing. Then usually they'll give you a range. Then let's say they've given a range for us to find the answers in 0 and let's use, okay, just to help in understanding, let's use degrees since degrees are easier to understand. But I'll be switching so that people are comfortable with both radians and degrees. So your focus there is to just treat what those brackets, whatever is in the bracket, just treat it as theta. So when you say what will be the answer there, so your answer there you're going to say, just look at it, just think of it as one thing and say 2x is going to be what? Okay, so what should be the value of that theta there? What sine half? People, what sine half? Hello? Okay, great. So it's going to be 30, right? So that's what? So that's 30 degrees. Now, what is sine? Sine is positive here, right? So meaning our answers are going to be where? Are going to be in the first quadrant and the what? And the second quadrant, right? So let's do it like that. First quadrant, second quadrant, third quadrant. Yeah. So meaning our answers are going to come from the first and second quadrant. So if we've got 30, meaning that where is what is going to be our second answer? And how do we find that? We say x is going to be 180 subtract that acute angle that we found. So that's going to be 150 degrees. So meaning your angles are what? That and 150. Now here is the catch. Uh these angles that we found is when we are assuming that everything that's in the brackets is what? Is just one pi. Okay, it's just one thing. Now, what is occurring for, or what is really what's happening here? It's that these particular angles that we are looking at, right? This 30, if this, think of it like this, if this theta is equal to 2x, meaning what should be the value of x? Meaning x should be what? X should be half of what? Should be half of these thetas that you found. Does that make sense? So meaning if you are going to find your x, which we are looking for, so we are going to get these thetas, those angles that we are going to get, so we are going to divide them by what? By 2. So to find x, we are going to say that since they've given us the range that our angles just have to be from 0 to 360, so we don't have to do that 30 degrees, then that one for adding by 2 pi 2 pi n. We don't have to do that because our they've already given us that, right? So then what you do, and then there are going to be certain times where, and I'm sure we'll look at one example where when you multiply your answer, it's going outside of the range. If it's going outside the range, don't include it in your solution pack. If you include it in your solution pack, you lose marks. Okay, so there we have it. So now what we're going to do, our theta there is 30 over 2, so that's going to be 15 degrees. Then x, that's 150. Then we are going to have, that's 75, right? So then what does this tell you? To think of it in a logical manner. What this particular question is telling you, or rather what we've done is basically telling you that if you get this x, okay? If you get this x 15 and you multiply it by 2, it becomes 30. Then you plug it into sine 30, you get half. I hope you've gotten the point. Then for what this is telling us, if you get this x, you multiply it by this 2 here, you are going to get what? 150. And this 150, when you plug it here, you get what? Half. And that's why both of these answers, they are in the quadrants where, of course, if even if they are both in the quadrants where sine is what? sign is positive. So that's how you go about these particular questions. Okay, so any questions? Hello, any questions? Yes, but we used it here. Yes. Oh, wait, like try to ask again. Like what's your question exactly? Oh, I see. Okay, so that's why I said that in this question, they've given us the range of our values. It's only between 0 to 360 degrees. But we know that from 0 to 360 degrees, sine is only going to be positive in two quadrants. It's when the range goes beyond 360 that it can go through again and we can get some positive values. You've gotten that, right? Like which values? Yes. It's giving you 195. Oh, you're saying that it will give us what? Oh yeah, oh my goodness. Oh yeah, oh yeah. Thank you so much for that. I guess I forgot that. Yeah. So we actually have to continue. Thank you so much for that reminder. So from here, yeah, thank you so much for that. So uh we see that we can still go further and further, and we're still going to find our what? We're still going to find our answer. So what we do for this one is, thank you so much for that. So what you do is, remember, we found our 2x like that. Then we found, let's do it like that. Okay, let's use radians. Radians are easier, but it will be the same thing. So that's pi. Anyway, we can even use this, there's no problem. So let's use 30 degrees. Okay, then we are going to be adding what? That's we're going to be adding 360. That's what 2 pi is, huh? 2 pi n. Then, yeah, so that's what's happening. That's for the first answer. Then for the second answer, we are going to have, we have 150, right? 150 plus 360n. Yeah, so that's that. So now, what do we do to get this? We know that we are multiplying by half, right? We are multiplying the angles by half, so that here we can remain with x. Then here we remain with 15. Then here we remain with 180n. Then on this side, the same thing. Uh, okay, so we have x, we have 75 and 180 n. So, or pi n if you want. So now, the wonderful concern that's been brought by our friend, it's this. So to find so the first angle we have, right? Let's make n to be 0. N being 0 meaning we are having what? 15 degrees. When n is 1, we are having what? That will be 180 times 1 plus 15. That's 195, isn't it? That's the answer that our friend told us she found. Yes. Then again, you can go. What about if our n is if our n is let's do n times 2. N times 2, it's going to be 180 times 2 plus 15, right? So this is going to be what? 360 plus 15. So 375, we don't accept it, right? We agree? So meaning we leave it here. Okay? I hope that's clear. Then we now go to this side as well. Thank you so much for reminding me of this. Oh my goodness. So uh, on this one again, the same thing. So let's go here again. So we know our first one is going to be 75. Then that's when n is equal to 0. Then if n is equal to 1, then we're going to have 180 plus 75. That's 255. 255, 255, 255. Okay, let's see. So we're going to have 255, and get 255. Okay, it seems interesting. Let's look at it. Okay, so is 225 within our range? Oh, sorry, 255. Yeah, yeah. So 255 is within our range, right? Yeah, and that's as far as we can go. Yeah. So you see, that's the That's the good thing about asking, because we could have left this important point out. So please, one thing is that I can make mistakes like this. Some things may slip off my mind and this. So always feel free to be able to reach out. So once again, to the one that asked the question, thank you so very much. Thank you so very much. Hello? Okay, so where exactly don't you understand? Okay, okay. Uh, so remember from what we had started with, we said that we said 2x. That's what this 30 degrees is representing. 30 degrees is not x. 30 degrees is 2 times x. Because remember the question was sine 2x is equals to half, right? So then we know that this particular uh, 30, it's not x, it's 2x. So meaning that x is twice what? Is twice 30. But then remember from the earlier parts that we are doing, the two questions that we started with, I said to find any relating angle to a sine, to a sine curve or to a sine function, you say 2 pi n. The same thing for cos. But for tan, remember I said for tan it's by n. Of course, we are looking at almost as though we are talking about their periods, isn't it? Okay, so now what is 2 pi n in degrees? 2 pi n is what? 2 pi is 360 degrees and n is n. So meaning that using this expression, you can then find what the values of 2x are going to be when we go through the circle as many times as we want. Of course, the number of times we were going around the circle, 360-degree circle, being determined by the what? Being determined by the n. So then if we say uh, the first round will be n1, okay? Sorry, no, sorry, will be n0. So that's where we say n times 0 times 360 will be 0. That's what? That will be going to be 30 degrees. And that 30 degrees divided by 2, you get 15 degrees. Then now we know that since all the angles that we are going to have, we have to have them. Huh? We need to be finding the half of them because they are twice the value of x. So what we do is that we just do this for the entire expression so that all the answers that we will be finding, they will be those of x and not of 2x. So what? So we multiply through by half. We are going to have x. We are going to have 15 degrees. Then here we are going to have 18 degrees. So again, meaning now the same procedure. We can then plug in a value of n from 0 to wherever the value be, but we have to maintain our range. So they gave us this range that all our angles have to be what? Have to be within 0 and 360. So then what happens here is that already we've got one angle. The first angle that we came out, we found is 15 degrees, and that's between 0 and 360. Now, how can we find the second angle? Is when we make n to be 1. So making n to be 1, we are having 15 degrees. That's going to be 180 degrees 1. So that's going to be what? That's going to be 115, 180, that's going to be 195. So that's 195. So meaning our second value then is 195. Okay. Okay, yeah. So that's how we are finding that. So yeah, so that's pretty much about this. Let's now look at another question before we can go on to look at quadratic equations of this kind. Once we've done the quadratic equations, then pretty much that's really about it with regards to this. So let's see this one. Hope time will be able to allow us, but at least we're just remaining with quadratic equations. Then we can start calculus. Okay, so that's the equation that we have. So this is cos is what? Cos is negative. So all students take coffee. So we see that cos is negative in the second and fourth, sorry, in the second and third quadrant. So meaning our answers, our angles are going to be those which are in the what? Those which are in the second and third quadrants. So what then are we going to look at? So what is, so again, like I said, treat that as one. Okay? So you're going to treat that as what? Treat that as 1. So then when you treat that as 1, what should be the value of theta? What should be the value of theta? Anyone? That's going to be negative. Is it really negative? No. Is it really negative? It's positive what? it really positive 30? Okay, so let's do this. Uh, is there any identity or those special triangles which you've done? And the main reason why I'm just asking these things is just to make you realize that you have to know these things on your fingertips. Like they have to be coming out like the way you might say your name. So that's why I'm asking you so that you can be familiar with them. So what's going to happen is uh okay, so if you look at this particular question, what would be our acute angle? So you always want to start from an acute angle. So you will realize that can someone tell me what cos 60 is? Just from those triangles of yours. What's cos 60? You know, what's cos 60? It's so it's positive half. It's positive half, right? Great. So why then am I asking? I'm asking because that's something that we are going to make use of. So what are we going to do here? So what we're going to do here is, so we know that cos cos half, okay? Cos half is going to be what? Is going to be 60. Now this is not the answer. Why isn't this the answer? Because if it's an acute angle, it's going to be where? It's going to be in the first quadrant, but we know that cos is negative. So meaning this answer is where? This answer has to be, so meaning the answers that we are getting have to be where in the second or third quadrant. But this answer is where? Is in the uh is in the first quadrant. So what do we do to convert? We say x is, and of course this is not x, of course. Being more accurate, we would say, okay, for now let's just use theta so that we don't mix things up. So we say theta, we say to find it in the second quadrant, we subtract from 180. So we are going to have cos 120. And if you check on your calculator, cos 120 is what? Is negative half. So that's how you come up with it. Then now you check what other thing can you do? Check for the third quadrant. How do you find something in the third quadrant? What you do is you say, more appropriately, you get this, the acute angle, and add it to 180. Then you're going to get 240. Then when you do cos 240, you see that you're getting negative half. Is everyone clear on this one before we can proceed? Okay, so if we are clear on this one, then now uh, we now then have to realize that these answers that we found, they are not equal to x, but actually uh, the relationship between x and these answers is this. Okay, so you get it, right? So then what do we have to do to these our answers for them to be relevant? So what do we do? So what then are we going to do? So like how you can think of it is this. If this if we are having two answers when we are rotating once, then we multiply these two answers twice, or rather we we double these angles, then we're just going to have one angle that's going to fit our what? Our range of 0 to 360. But let's do it so that we can appreciate. So what's theta? X is equals to theta is 120. So let's find what x is. So x is what? Is 240. Okay. Now again, if you'd want it to be really really okay, like we did it for the other part, you could do that. Then plus 2 pi n. Then you would also want to put what? In this case, you are multiplying by 2. Okay. So that's what you are doing. Then you get x is equals to 120. Oh, sorry, we are using degrees, so we have to use 360 n. So you are going to have 120. That's going to be 720 degrees n. Okay, that has to be 240. Pardon me. So that's going to be 240. Okay, then we could do the same for this part as well, for the other answer. I know we've run out of time. Let's just wrap up with this so that we can start on quadratic equations tomorrow. Okay, okay. So now let's now try to look at these answers. So now let's start with the first one. Let's put n to power 0, or n to 0 rather. If n is 0, our answer is going to be what? 240, right? If n becomes 1, it's going to be high. It's going to be above that. Sometimes we say, okay, let's try -1. I say when you put -1 again, we are going to have that minus that. So you see, we get a negative answer. So it's not going to be what? It's not going to be in our. So what does it tell? Sometimes they'll give you a range such as -180 to positive 180. That's where these things come in handy. So sometimes you can plug in a -1 and you might get a negative answer that may actually be an answer, but because of the range that we were given from 0 to 360, that's why when we put a negative there, we see that the answer becomes negative, of which our range is from 0 to 360. So that's basically how you do it. So from this, how many answers do we have? That's the only answer that fulfills our range. So that's something that's very very important to take note of. So we meet tomorrow. We look at how to solve quadratic equations using identities and things like that. So meaning this particular question only had one answer, because for this, no matter what you do, because when you put n is close to 0, you're still going to get this. It's going to be higher. It's going to be higher. So this one you don't. So when you're writing your answers, you only include which one? This one. So that's pretty much about it. I don't know if there are any concerns with regards to this topic, but